quickly define a term called kurtosis. Now, for a normal curve, the green curve that you see here is a standard normal curve that you find. There could be some instances where the curve is either more peaked or flatter than the normal curve. If it is more peaked, effectively what you will find is that it has fatter tails. So instead of your normal curve, which would be something like this, if the curve is more peaked, it will have a fatter tail. It is called leptokurtic. It effectively means that the probability of extreme returns away from the mean or the mu is higher as compared to a normal curve. A normal curve is called mesokurtic. A curve which tells you about extreme possibilities of higher or lower return is leptokurtic. A curve which is flatter, which means effectively lower possibility of extreme returns, is called platykurtic. Why are these important? Leptokurtic, effectively all equity returns are considered to be, or they have been observed to be leptokurtic, which means there have been significantly big moves. For example, in 1987, on one day, the US market fell 22%. This is a leptokurtic move because effectively under normal distribution assumptions, this move is practically impossible. It cannot occur in many million years effectively, but it occurred. There are other moves that happen, which means equity returns are effectively leptokurtic. Kurtosis is the measure which tells you if the distribution is more or less peaked effectively, or effectively if the possibility of extreme events is higher. So here that possibility is higher. You can remember this by saying that the curve is also higher. Fine. So that's your kurtosis. Kurtosis, just a mathematical number, technicality. The kurtosis for a normal curve is 3. For a standard curve is 3. You can calculate it. It will give you a kurtosis of 3. Excess kurtosis is 3 minus whatever is the kurtosis. So excess kurtosis for a normal curve, which is mesokurtic, is 0. Fine. Don't need to remember all this. Just for quick technicality, I am